Okay, so what is Kafka? Why it is required? So before going to discuss about Kafka, first we'll see some why we need that. Alternately, Apache Kafka, what we can have. So the first thing is generally the user, a person, a human, how much data will generate daily? How much data is generated daily? Is it 1 MB or 10 MB? And on average, how much you are thinking? Before giving answer, just consider some points. What are some points? You have mobile. You have mobile. In the mobile, you open the Flipkart, Amazon, Facebook, Insta. Okay, you do something, some operations. Okay, searching for the friends, watching the reels. Okay, going to the like Flipkart, Amazon, search some products. Okay, put in cart. All those things you do generally, right? And on average, every human will use at least 1 or 2 hours per daily. Every day, at least 2 hours. So just think each one application will take at least 10 MB, at least 10 MB. Okay, then consider for the all applications, it may be 50 MB or else maybe 100 MB. Okay, so nowadays we know every person using mobile. Okay, using continuously day and night. In that case, consider how much data is generating by each person in terms of MBs and GBs only. Okay, that number of huge data, how to handle that number of huge data, how to handle in terms of storage, in terms of processing, in terms of analysis, how to manage all those things. For that purpose, we have some big data systems. Okay, there we store and analyze and process the data. Okay, simple application, simple example I'll take, then I'll go directly to the Kafka only. Okay, how to install those things. So I'll cover some basic scenarios. So in Flipkart, maybe think like in Amazon, Flipkart, okay, Myntra, any online shopping application. What you do generally, you want to buy one mobile. You want to buy one mobile. What you do? You go and search in Flipkart. Particular mobile, what is the price, what are the features, what is the any offers for that. Okay, all those things you search. Again, you'll go for the Amazon, you search, you check the difference, and again go for Myntra. Like that, you search at least 3 to 4 websites, and you will get some analyze, you will get some overview on that where you have to buy. Based on price, based on offers, based on features, you will decide where to buy. You will decide where to buy. And after checking the information in the website, in Amazon, Flipkart, if you open the Facebook or Insta, this kind of application, they will show suggestions similar to that product, right? They will show the suggestions similar to that product. Just you are searching for mobile in Amazon. If you open the Facebook after some time, in the Facebook you will see some ads. The so and so mobile is so and so rate, so and so some features and offers. These things it will show. How the Facebook know you are searching some product in Amazon? How the Instagram know you are searching for product in Amazon? How Twitter know? Okay, how they are communicating. So indirectly, your data, Amazon sharing with the Facebook. Okay, Amazon sharing with the Instagram. Amazon sharing with the some other application. How they are sharing? So how many number of users is searching the products? You are searching mobile. I'm searching laptop. Someone person searching for some other product. But finally, those applications sharing data with some other applications. Okay, online shopping applications sharing with the social media applications. How they are sharing the data? So and so user, so and so item is searched in the corresponding application. So you can show similar type of items to them in the shopping application. Sorry, social media applications. how they are frequently communicating, how they are sharing the data. That is very much important, because here don't consider only you. Like you, there are millions of people. Okay, millions of people per day, they are searching products in the Amazon, Flipkart. That data sharing with the Flipkart. That means this many times two applications is communicating. Okay, how these are communicating? How these are communicating? So generally, already I told, one application wants to communicate with one other application. How it will communicate generally? Already I told the REST API applications. Okay, we have Redbus application. We have some payment application, HDFC Bank. How they are communicating? What is the technology using that? In area? How one application is communicating to another application? So it is using some REST template kind of objects to come with the HTTP protocol by using JSON or XML as a mediated language. One application is communicating to another application. Think like same way. We have this side. I'm taking Flipkart, Amazon, some other maybe Myntra like that. You can take any yours. On this side, I'm taking the Facebook, Insta, Twitter. If we take multiple also, just for understanding purpose, I taken 3. This is Amazon application.
Communication between applications by using REST web services and only.
Yes, correct. REST services by using REST, example REST API. In that we are using REST template object, REST template by using the JSON or XML as a language.
Only we can come only REST template. There is no other process for communication.
We have multiple approaches. I discussed REST template, right? That's why I told. We have
sure.
Advanced one. We have web client. This is also one approach like that. Okay, here I'm taking the Facebook. What else we have? Popular social media applications. Okay, so you are searching some item, maybe mobile in the Amazon. Okay, after some time, that product as a suggestion, as an ad, you can see in the Facebook, your Facebook account, your Facebook, not others. Amazon sharing with data with the Facebook. So, sorry, okay, fine. Amazon sharing data with the Instagram. Okay, Amazon sharing with the Instagram also. Amazon sharing with the Twitter also. Why these are sharing? Maybe the Flipkart and Amazon, they have some contract. When a user searching some product in their website, that has to be give information to the corresponding Facebook or Insta or Twitter. That is their contract. Okay, same as you are searching some item in the Flipkart, so that will auto show the in a Facebook. It will show in Insta. It will show in a Twitter. Same as here also we are searching some class. It will show in Facebook. So Myntra will sharing the data to the Facebook, Insta, and Twitter, so that they are showing as ads in our account. Okay, just simple here. Only one product you are searching in a one website. One website that is sharing with the 3 different applications. Amazon sharing with the 3 different applications. How this will be communicated? See, if we are using REST API, in the REST API, how we will call? Already we know that we have corresponding Facebook URL. Okay, Facebook URL on HTTP request type. Okay, request body data or query param or path param. Based on that, we'll communicate to Facebook. Same as Insta, same as Twitter. Tomorrow, if you want to, maybe take this scenario only. So in this case, how many calls Amazon has to do to show the ad? Okay, Amazon has to call with the Facebook, Amazon has to call to Insta, Amazon wants to call to the Twitter. So tomorrow, some other application wants to share. So what is one more example you can take? What we can take here? Twitter, Insta, Facebook, LinkedIn you can take. So tomorrow LinkedIn also wants to show the ads from the Amazon. What they have to do? They have to talk to the Amazon people. They have to talk to the Amazon people, and then Amazon will give the URL, username, passwords, maybe URL, username, some details, HTTP request details. Then they will communicate to the Amazon to the LinkedIn. Okay, so here maybe LinkedIn sharing details to Amazon, so that Amazon can call the LinkedIn. So tomorrow there are going to change applications, more applications going to add, more calls it has to do. And for one person searching one product in Amazon, they have to call 4 HTTP calls to different applications. This is not burden. One user giving request, maybe searching some product in the website, it is going to the 4 applications. It is going to the 4 applications. So how much is burden? Take one more example. Maybe 1 million users searching their own products in the Amazon. How many calls it will go? It will go 4 million. It is not burden to application REST API. Definitely REST API will go on dead the application. Okay, REST API will go down because this many calls in a fraction of seconds, it will not be possible. It will not be possible. Frequently it has to say data, right? It is not possible to send this many requests to different applications because that application cannot be handled. So how to solve this kind of problems? How to solve this kind of problems? Just see another diagram. I'm writing same. So by using messaging systems, how we can solve this? See, then you can understand why we need maybe Kafka, RabbitMQ, those kind of applications. So let's see one example. Same, I'm taking Amazon, Flipkart. Last one is maybe Myntra. Next one is I'm taking here Flipkart. Sorry, what is this? Facebook, Insta, LinkedIn. Okay, LinkedIn. So here in this case, there is one middleware component involved, one JMS queue, one JMS component, messaging system. In this messaging system, we will put messages. Okay, what the message will put? User number 1 trying to search the ID, signs of the mobile number, maybe mobile model in the Amazon. Okay, like that. Take Amazon here first. I complete the diagram. Here is Facebook. Okay. So here I'm searching some item in Amazon. Okay. How this will communicate to Facebook, Insta, LinkedIn? This will not communicate directly. There is some mediator called JMS component. That may be Kafka, that may be RabbitMQ, ActiveMQ, that different components are there. Okay. I'll write maybe Amazon write information, so and so user, so and so mobile searching in the Amazon. Okay, and from here different applications, maybe Facebook can read, Insta can read, LinkedIn can read. Okay, and read data and it will show the ads in a corresponding application. And same as Flipkart, I'm searching some item in Flipkart. So Flipkart directly don't contact Facebook or Insta, LinkedIn. It will contact the mediator JMS. Okay, here I'll show some message. Simply message we can call it event. I'll show some message. In the message, I'll tell so and so user ID 1 searching for the mobile. Okay, searching for mobile model, something I write here. That will be consumed by the Facebook or Insta, LinkedIn. These three also can consume. Okay, not only one, these three also can consume. And same, I'm searching some class in the Myntra website, and that Myntra website will store that event in JMS. From here, different social media applications can read and they can show the corresponding information in the ads. Okay, tomorrow one more application is coming. Maybe Twitter. You can take an example, Twitter. Okay, this Twitter application wants to Amazon wants to show ads in Twitter also. In this case, Twitter going to read from directly Amazon as a mediator. It will go directly mediator. It will go mediator and it will store the, maybe it will get the data and it will show as a ad. Okay. In this case, there is a dependency will be reduced. Dependency will be reduced. In previous case, what will happen? Maybe Facebook URL got changed. Facebook URL HTTP type got changed. Okay, request parameter got changed. Request, maybe response body changed. That time there is no dependency because here there is a dependency because in Facebook some URL got changed that has to reflect in a Myntra, Flipkart, Amazon. These three places has to be changed. Otherwise, they cannot share the information. But in the below case, if you use JMS, if you change the Facebook URL, if you change the Amazon URL, maybe the request data, response data, whatever, it will not affect much. Only it will store data in JMS. From JMS, different applications can read. Okay. In this case, technically, if we discuss this side, we can call it as producers. Producers producing data. What data? So and so user trying to search some data in my website. Okay. Producers will data produced to the JMS. Then these people are consumers. What consumers do? Consumers will consume the data from the queue or JMS. Okay. And it will show the data in a maybe ads. That is a fine. In this way, there is no dependency. This is the main thing. There is no dependency. This is the main thing. And what are different JMS components? What are different JMS components? That we'll see now. We have different, maybe Kafka is a newest one, but previously we have ActiveMQ, RabbitMQ, like there are many systems, JMS system. Okay, recently Kafka got introduced. That is, I think, 2011, that type. Okay, what is the benefits of Kafka? So we are not discussing in depth of RabbitMQ. Okay, in depth of Kafka, nothing. We just will discuss how to work with by using Springboot, how we can work with Kafka. Okay, first we need to know about what is Kafka. Okay, how to set up locally, what are different concepts there. Those we'll learn, then we'll go for the example. Okay, so we'll see Kafka now. So first, why we need JMS system? Why we need JMS system? Messaging system, Java messaging system is fine. So why we need? Whenever data is more, generating more, we have to communicate to another systems. Okay, that time there is a performance issue. To avoid that, we can go for some messaging systems like ActiveMQ, RabbitMQ, Kafka. Now we'll see Kafka. What is Kafka? Kafka is a open source distributed event streaming platform. This is open source, data is distributed. Data distributed means data will be distributed to different applications and also, okay, that will go later. So data will be distributed through different applications through Kafka. Okay. And Apache Kafka is used to process the real-time data feeds within a high throughput of low latency. So data will be feed. Okay, how data will be transferred one application to another application with a high throughput. How throughput means there is no delay, low latency. Low latency means there is no loss of data. Okay, Kafka work based on publisher and subscribe model. So I told you already here, this is a publish and subscribe or consume or produce. Some maybe words are different. The meaning is same. The meaning is So meaning is same. So here I told producers, consumers, we also can say these are publisher, these are subscribers. Okay, these are subscribers. This is released in 2011 by LinkedIn. The LinkedIn company is implemented Kafka. Later, it moved to the Apache product. Okay, Apache is a company. Later, it is by the Kafka component. Okay, initially developed by the LinkedIn. Later, it moved to the Apache. Okay. Now, what is the Kafka features first? What is Kafka features? So, throughput is a one major feature I can say. So, in this Kafka, the messages will be transferred very high throughput. Very high throughput. Like we have multiple machines here, it will share to the different applications. And scalable means cluster will be shared. Here we have example. Here we have only one JMS. Example, one server is there. In that case, what will happen? Amazon writing data to the JMS, Kafka. Okay, Amazon writing to the Kafka, that is fine. After some time, there is a network issue or there is a Kafka system OS failed. OS failed or network issue, something it got down. It got crashed. Then what you do? Complete data will lost, right? Once the system is down, the data will not read by the Facebook, Insta, LinkedIn. Okay, to avoid these kind of things, Kafka can maintain with the different systems. Same data we can maintain to the different system. Like that, we can store data in a different systems. It will be scalable. This will be scalable. That is called, you can increase the systems and you can share the data. While even one system is down, the one system can be still served. There is no chance of data loss. Permanent storage means even the clusters shut down and restart also, data will be available. It's not in memory. High available data will be high availability. This will be, you have to manage the servers. One server has to place in one region, maybe in Hyderabad. One server may be placed in Mumbai. Another server may be placed in a US. This kind of architecture we can follow, so that even one region is failed, remaining regions still will be continue the request. Okay, we can connect different systems across the global. That is a high availability concept. Built-in stream processing. We have like some aggregations concept, filter concept in the Kafka. By using those, we can process our messages, whatever receiving to the Kafka. Client libraries. What are client libraries? Client library means, so once we develop a Kafka, this data we have to read by using different languages. Maybe Facebook is developed with the Java, Insta is developed with the .NET. Okay, maybe in LinkedIn developed with the PHP. Like that, even if you use multiple languages, the multiple language support also will be provided. By using different languages, still we can connect with the Kafka. That is called client libraries. So we can read and write, process the data by using different programming languages. You can go for next. This is interesting topic. How to install Kafka in our Windows. Okay, this part in companies will do by the DevOps team, maybe admin team. They will do the installation, setup, everything. Basically, we have to just use those. Okay, but in our local, we have to practice. We have to learn the components. We have to learn the concept. So we have to install. We have to practice. So how to install? How to install in our Windows system? Okay, I'm going to teach in Windows. Maybe Linux also similar case. Mostly similar. Just download the Kafka from this URL. Go to browser. One second. So, how to download? Go to here. Maybe this link downloading is fine. Apache Kafka. This is official documentation. This is the official documentation by Kafka. Okay, here go to download section. You can select any your choice which one you have download version. I'm taking the 2.13. This 2.13 is Scala version. Kafka version is 3.4.0. You can take anyone, not specific to any particular version. Download, click on this, download, download the corresponding file. Okay. After downloading, what we have to do? After downloading, just extract the file. Extract, I already extracted. I'll show that. Apache Kafka is extracted. Okay. This is the file you downloaded. .tgz. This is the file extension. Once you extract that, you have to create a tar file. After that, again extract, it will generate this folder. Okay, 2 times extract required here. Just remember that. And next, go to bin folder. In bin, we have these are some scripting files, shell script for the particular to Linux. So we are using in Windows. Go to Windows folder. Here we can see the batch files. Batch files are specific to the Windows. Okay, shell script are specific to the Linux. Windows specific is batch files. Here we have see Windows folder, and we have all set up for the Kafka. Just what we have to do? Start the Zookeeper. What is Zookeeper first? What is Zookeeper? Zookeeper will maintain we have diagram also somewhere. Okay, just take this for now.
So now you downloaded only Kafka.
What is it?
Sorry. Now you showed about Kafka download and the batch files and shell.
Yeah, now I'm showing how to download Kafka, how to set up in our local, how to work with that.
Already you downloaded Kafka. Why we need Zookeeper?
I will tell what is the purpose of Zookeeper. I will tell. Just I just started, right? Okay, just example take. This is a Kafka cluster. Yeah. This is a Kafka cluster. Cluster means what? Multiple Kafka instances. Okay, so these are Kafka cluster. So Kafka cluster means multiple Kafka broker servers. This is one server, Kafka server. This is another server. This is the third server. There are totally 3. Okay, sorry, 1 second. How to highlight this one? Okay, this is the first one, Kafka broker, another broker, another broker. These 3 in the single server. Kafka broker is a single server. That means this is the one system. Top one is the one system. In one system also we can launch multiple brokers. Okay, this is the second system. In the second system only one broker is there. So to maintain all this broker, to maintain all this Kafka, where we install Kafka, that we can call as a Kafka node, or in that where we started Kafka. Okay, in single node also, single system also, we can launch multiple Kafka brokers. That is why we see 1, 2, 3 Kafka brokers. Okay, in the second node we see only one broker. Okay, this we can call a simple Kafka cluster. This cluster is connected to the Zookeeper. Just observe this line. This cluster is connected to the Zookeeper. Cluster maybe node 1 and node 2 both are connected. What is the reason? So Zookeeper, by seeing name, understand keeper. Keeper means will monitor. Zookeeper always monitor the Kafka nodes. Which broker is going to down. So unfortunately, there is some issue. The broker 1 is down. Broker 1 is down. In that case, what you will do? What you will do? Whatever data is there in the broker, it will be lost. Okay. And also Kafka cluster has to know this broker is down. Okay, Kafka cluster has to know this broker is down. So who will monitor those? Which is up, which is down, which is working properly, which is not working? That is component called zookeeper. It will monitor all the Kafka broker nodes, all the nodes on Kafka broker, which broker running, which broker not running. Okay, all these things will be managed. Okay, that is the main purpose of the zookeeper. And one more in-depth concept, in the nodes also, in the example, in the Kafka nodes, we have Kafka 1, Kafka 2 nodes. 2 nodes are there, totally 4 brokers are there. Okay, in the 4 brokers, if you have internally, it will be distributed into partitions. It will elect the leader. Okay, how we'll go vote outside? Okay, if there is MLC, MLA elections, how we'll do voting to elect a leader? Here also, zookeeper will decide who is the leader. Okay, we have 4 brokers here. If I send one message, I am a client Amazon trying to write some message to the Kafka cluster. This message where it will store? Where it will store? So this will be decided by the leader part of the brokers. Leader part of the brokers. Okay. Example: a broker 2 is a leader. Broker 2 is a leader. Then this broker 2 is responsible to store this message in Kafka cluster. Okay. Understand, right? Broker 2 is a leader to store this message in the Kafka cluster somewhere. Okay. And unfortunately, maybe the broker 2 leader is down. Broker 2 leader is down. Then who will responsible to store the message to Kafka cluster? Who will responsible? That time zookeeper will understand. Okay, zookeeper will understand there is a broker 2, it's a leader partition, leader broker. It is down right now. So is there any incoming messages coming to cluster? Who will handle that? That time immediately zookeeper will go and check. Apart from the cluster 2, how many Kafka brokers are there? We have remaining 3. In the remaining 3, zookeeper will elect again. Will elect one new leader. Will elect again one new leader. So maybe this time leader will be this one, Kafka broker 1. This is maybe leader. So right now I'm writing L here. Okay, this is the leader. What that means? If any incoming message coming to Kafka cluster by writing different application, Amazon, Flipkart, whatever, that messages will be taken care by the leader part. Who is the leader now? Kafka broker 1. This Kafka broker 1 will take this first, then it will identify where to store. Maybe it may store in different broker, same broker, different broker. That is maybe decided by the Kafka broker. Okay. What is the first thing of the purpose of zookeeper? So zookeeper is used to manage and coordinating Kafka brokers. Zookeeper serves mainly coordinating between the Kafka broker and Kafka cluster. What are different brokers are there in the cluster that will be managed. Kafka cluster is connected to zookeeper to get the information about any failure nodes. Any failure, not only failure nodes. Tomorrow there is new broker coming. Okay. Here 1, 2, 3. Maybe there is a 4th broker I'm adding. 4th broker I'm adding. So that 4th broker, okay, adding to the cluster. Then who will decide? Who will decide? This is the 4th broker newly came to our cluster. So this is the 4th broker. So who will decide? There is a new broker coming to my cluster. I have to store that there also data. This will monitor with the zookeeper only. Zookeeper will decide, maybe will be monitor which broker is going to down, which broker is down, which broker newly added. That data will monitor and information will set to the Kafka cluster. Kafka cluster will be set the data, store the data. One more thing is, okay, first one is to monitor cluster. Okay, second one is electing leader broker. I'm telling now later broker now, maybe it will change the later partition. Okay. Leader broker will be elected. Even when anyone is down, leader is down, in that case, it will elect, it will be decide who is the next leader. Okay, that is about zookeeper component. So next one is, so first we'll start zookeeper then, because zookeeper is a main component here. I'm starting this. How to start? Where is installed? Go to this location. CMD. Install CMD. There is something called PowerShell. You know PowerShell? Terminal. Just take this. I'm running here. This command. I'm already in bin Windows folder. I'm already been in Windows folder. That's why I'm removing this one. Okay. I'm starting the zookeeper. It is giving error. Command was not found. Not correct. Okay. Windows, go back one step. One step back. CD space. No, paste again. Okay, it is started. So zookeeper is started. Just I'm renaming here. This tab represent zookeeper. Okay, here zookeeper running. In the next tab, what we are going to start? See here. Next one is we have to start Kafka broker. What is Kafka broker? Here in my system, I installed Kafka. So I install Kafka. I can launch Kafka here. If I launch first time, it will be Kafka broker one. In the same place, if I launch another broker, same Kafka start command, another broker. If I run against Kafka start command, another broker, like that, it will start the multiple brokers. So here I'm starting only once Kafka broker command by using this one. So Kafka broker, how to start? This is a command. Bin Windows Kafka start, Kafka server start bat. Okay, that needs one argument, input argument, that is a server properties file. Where is this server properties file? This zookeeper properties file and server properties file are there in a config folder. Okay, see here, server properties file, zookeeper properties file. Just open one and see what are different configurations required. We are not admins, that's why I'm not focusing much on this. This is the zookeeper port number. This is the zookeeper stored data. Okay, like that, there are many things here. Just I'm showing where is available. Now I'm starting the Kafka server. Okay, just remember, if we just started this part, we just started this part. Next, we are going to start Kafka broker. Maybe this is the one broker. Okay, this is the one broker. This is the one broker. These are all three brokers only. So just I'm starting one broker here by using this command. No, this location is not correct. Location is this one. CD. What is CD command? It is Linux command or Windows command also to move directory. Okay, run this again. Kafka server broker started. Okay, Kafka broker started. Up to now, how many done? This is completed. This is completed. Next, we have to start consumer part. Here we have multiple consumers because this is a cluster. In my local, only one system is there. That's why I can take one consumer is fine. Okay, consumer part we are going to start. Okay, giving number also. This is the first start. This is the second one. This is the third one. So to start consumers. The producers and consumer. We can start producers consumer parallel also, but it needed topic name. Okay. So before starting consumer, there is one task we have to do: create topic. What is the topic? What is the topic? So in Kafka cluster, where we have to store? in Kafka cluster, where data will store in Kafka. This is a Kafka. This is a cluster. Okay. In that, where to store? Maybe I want to divide. I want to divide. Example: Facebook and Insta. Facebook and Insta go and read from the one topic, one place, and LinkedIn, Twitter, I want to read from the another place. Okay, another place. This place we can call it a topic. This is the one topic. This is the another topic. Okay, why? Because maybe in the Facebook, Insta, I want to show only mobiles. LinkedIn, Twitter, I want to show only laptops. I want to divide like that. I want to categorize. That time I can write laptop information here, mobile information here. So now, while the consumers or producers trying to read, maybe producer trying to write, it will write here. Okay, this will write the another topic. So I want to segregate. That's why we can create a topic. So Kafka cannot store data in only one place. There is no use for that. It has to divide into topics. Okay. Topic means what? I want to show only mobiles whenever user searches only for mobiles. Then go for the one topic. I want to show user searching for the laptops. Then create another topic. Okay. If you subscribe, maybe Facebook is subscribed to mobiles, it will get the one mobile data. Facebook can also subscribe to the laptop also. That is also possible. So one consumer will subscribe to the topic. Okay. I'm taking simplifying here. Amazon. This is Amazon. This is Facebook. Okay. This is Kafka. Okay. In that, this is one topic. Topic name is mobile topic. Laptop topic. I'm creating another topic called class. Okay. So Amazon writing data to the mobiles topic. So Facebook wants to consume here. Okay. So Amazon writing here to mobile topic. In the Kafka only mobile topic, particular place, particular category. So that now Amazon wants to, this is the producer. We can call it a producer, or we can call it a publisher. Publisher, producer, different names. Okay, these are consumers or subscribers. Okay, whenever message received, whenever message sent by the producer, then consumer will be consume the message. Okay, consume the message. So from where it is consuming? So producer writing the one topic, the particular topic name, it will be consumed. Okay, that means what? Consumer always look eye on the particular topic. Okay, so this Facebook also want to read from the laptop, then consume here also, class here also. That is the approach here. Okay, what we want, like that we can segregate. This is called topic. Okay, particular space we can call it topic. So next we'll create first topic. What is topic name? I'm taking this command, and I will explain what is the each one here. Kafka, okay. Kafka here topic. While creating topic, this is the command Kafka topics.bat to create a new topic. Okay. Further, we have to pass some parameters input to create a topic. For the input, first input is topic name. -hyphen topic. See topic name. Example: mobiles. Mobiles is one topic. Okay. And I'm telling to create topic. We are creating or updating as what is that we are doing? That is called creating. Booster servers. What are booster servers? Where is the Kafka broker? Booster server means Kafka broker. Okay, which broker we are going to store the data? Which broker going to handle request? And partitions. What is partitions? Partitions topic is, I will tell quickly, try to understand. So whenever we are storing data, so sometimes data will store here in the broker one. Okay, it can store here broker one. Okay, can store here, different places we can store. How to store? It will divide into the different partitions. Different partitions. This is a partition, and there is one more concept called replications. What are replications? Replication means how many duplicate copies. So we can store here. This is one copy, copy number 1. This is copy number 2. This is copy number 3. Okay, this is all are stored in only one node. This node is down. This is a problem. That is the purpose. We can replicate into multiple partitions, multiple maybe replications. This is 1. This is 2. Okay, this is 3. Even this is down. This is still available. Even this is down. Here, this is available. Like that. That is called replication. Replication means number of copies. Okay, first I will tell partitions. Partitions means where to store data. Which partition? Okay. Second one is duplication factor. Duplication factor means how many times data has to be duplicated. How many times data or message duplicated. Why we use duplicate? Why we use duplicate? Generally think. Example, you have your marriage videos. Your marriage video is there. Okay, the studio person given to you as a on CD format. What you will do? You will keep like that as CD format only. For safer side, you will distribute. Maybe you will copy into multiple CDs. Okay, you'll put into one in Birva, one is in some other place, one in some other place. What is the reason? Even if you lose that one place, remaining place still available. Okay, maybe the studio person given as a pen drive. What you will do? You will copy into different places. One is in Gmail, another one is Google Cloud, maybe another maybe in some Cloudera form, not Cloudera, some maybe some cloud location, hard disk. Like that, we can use some different places to store your data, important data. Why? Because even one place if you lose, remaining places still available. That is called high availability. For the purpose only we can do that duplicates. Even one place is lost, you can get back from another. That is called replication factor. So I am telling here replication factor is 3. Okay, execute this one command. Another terminal. This is broker. This is topic creating. Topic name is mobile topic. Okay, if you use this command, error. Okay, we have only one cluster, right? One broker. That's why we can use only one replication. Only one is possible in local system. We can't have only one broker. So I use the only one replication. Topic is created. Okay, topic is created. So in up to here, what we did? Zookeeper started. Okay, broker started. And third one is topic created. What is the topic here? Okay, topic is created with the diagram. Last number. Okay, I'm writing here. Topic is created. What is the first step? We have to start the producer or consumer. First we start producer. Producer will send data to the Kafka. Okay, first we start. Okay, so this is created Kafka broker and topic will created, and to monitor Zookeeper also is created. See, Jupyter is also created. Next we start the producer. Producer will send the Kafka messages to the cluster. Okay, how to start producer? Producer like this example, Amazon wants to send data to the Facebook. This is to start producer. Okay, take this command and analyze what is the different commands are there here. Different parameters. To start producer, this is console producer. Okay, we want to send some messages from the console. What is the some console? By typing keyboard, you can send some message of Kafka servers. Okay, by using console producer. This is default producer given by the Apache Kafka. If you want to write, Amazon wants to send a message, so we have to write some code. That is custom producer. Okay, Amazon is a custom. Flipkart is a custom producer. We can use some Java code, some different languages code, okay, to create custom producer. But here, Kafka provided to practice yourself. Some producer given, there is a console producer. Okay, for console producer, we have to tell topic where we have to write. Where we have to write. So I'm telling here Amazon, write here mobile topic. How to tell? While starting the producer, I have to tell the topic name and Kafka broker name by using this command. Okay, topic name is mobile. Bootstrap server is localhost line name. This is Bootstrap server means there is a Kafka broker server. Run the command and see. It is started. It is started and waiting for the response. So waiting for the some input. Okay, waiting for the some input. We'll see that input over later. Rename this as a producer. Okay, Amazon producer, better name. Amazon producer. So Amazon connected to the Amazon is connected to the Kafka server now. Kafka server particular topic is mobiles. Okay, now Amazon ready to send a messages. To send a message to the Kafka topic. Now we have to start consumer. This is Facebook. Okay, this will consume data from the mobile. After consuming, what they will do? That is that Facebook their business logic. But I'm telling now how to consume data from the corresponding topic. First, we have to start the Kafka consumer, console consumer. Okay, this is the command to start consumer, console consumer given by the Kafka default one to do practice, just only for the practice, because no one will send command line in the real time. So we have to tell from where we have to read. This is the topic name, and from beginning. Okay, even before starting this consumer. Before starting this consumer, Facebook, there are any messages already that also we can read by using this flag from beginning. Okay. Next one is Bootstrap servers. This already you know. CD. Start the consumer. This started and waiting. We started and waiting. Okay, now see, I'm renaming this one. It is Facebook consumer. Facebook consumer. Now, what happened from the diagram is Amazon producer ready to send the messages, and consumer Facebook is ready to receive the messages from the topic. Okay, if I send message to this topic, immediately consumer also will ready to take the message. Okay, just see that. Producer I'm sending some message, simple message, hi. Immediately see this corresponding consumer issued or not. Okay, another message I'm sending, I am searching for iPhone. 14, yes. Consumer send the message. Immediately, consumer is here sending a message to topic. I am searching for the some iPhone 14s something. Okay, it is stored in mobile's topic. Immediately, consumer producer send message and consumer reading message from here. That is already read or not. Immediately see here. We got a message immediately. This is kind of chatting application. This is kind of chatting application. So we can observe here. Sender is sending. I'm WhatsApp. Just consider this is WhatsApp. I'm sending message. Hi, how are you? This is received here. This is received here. This is only consumer. Consumer only can read but cannot write. Okay. Here consumer, Flipkart or Facebook. This is a Facebook. Only can read the message. Consumer. Producer only can write the message. Okay. Only can write a message. Like this, consumer and subscriber. Kind of model. This is the Kafka implemented. Okay. By default, I worked with a console consumer or console producer. This is a default one, just only for practice. Only for practice. I am sending one more message. Dell laptop model 1024. Okay. I searched in a place Amazon. Amazon shared to the Kafka. From Kafka, another application which is Flipkart, maybe Facebook, read here. Okay. Based on this corresponding this message, maybe Facebook or Amazon, sorry, Facebook or Insta will show the some ads to you, some suggestions to you. Like that, data will be shared to the application. So tomorrow what will happen? Tomorrow what will happen? Instagram consumer also, here I am adding, Instagram consumer also wants to read from the, where is this? Okay, Instagram consumer also, you see Instagram consumer. Consumer also wants to read from the mobile's topic. Whatever Amazon sent, the data wants to read by Instagram also. So Instagram later came. Already we have some messages in the topic. Hi, okay, I'm searching for iPhone 14s. I'm searching for Dell laptop model something. Already some messages are there. After Instagram consumer, you see Instagram consumer started, the old message will be received or not. That flag will be tell by the from beginning. While starting the consumer, you see the consumer starting component. Okay, script, bat file. With this bat file, we start the console consumer. Okay, if there is any message in that corresponding topic, okay, already in messages are there. Those messages also I want to read. Okay, I'm telling Insta consumer whatever message is already there before I start. Okay, already there. Those also I want to read. Then I have to mention this flag. No much conflict, no much difficult. This simple tag you can tell. If you don't tell, what will happen? The from beginning, if you don't tell this flag, what it will do? From after starting the Instagram consumer, any message sent by the producers. After starting any message sent by the producer, then that message will be come. But previous one will not come. That is the from beginning habit, from beginning keyword. Okay. Now I'm starting one more console consumer. Okay. I'm starting. See, how I got all these messages. Example, this is we can call it Instagram consumer. This is just now started. But I got old messages also. Old message which is sent by the Amazon. How? Because I mentioned this flag. Okay, it is not clear. Now what I will do? I will launch one more consumer. I will launch one more consumer, which is LinkedIn consumer. LinkedIn application consumer reading the data from the mobile topic. Okay, linked in consumer reading from the mobile topic. Now I don't specify this flag from beginning. I don't specify this flag. This time, whatever already messages are there in the mobile topic, hi, okay, I'm searching for phone, I'm searching for laptop. Those messages will be read or not, and just check now. I'm starting the one more consumer. What is the consumer name is? LinkedIn consumer. This is LinkedIn consumer. I did not given right. This from beginning. From beginning, I did not given that keyword. That is why this is not get the. This is not get the messages. See, old messages are not came, but Instagram consumer old messages received already. Now check. Now give me answer. Please respond. How many consumers are there? How many producers are there right now by seeing this diagram? Respond, please. Very important topic. This is your request only. That's why I'm covering. How many consumers? How many producers are there? Why no response?
Only one producer.
Okay.
And two, three, I think two consumers.
Please repeat. How many consumers? How many producers? Almost correct. Just see the diagram and tell. No problem. If you are giving wrong answer, I'll correct you.
Only one producer and three consumers.
One producer. It's a one producer, three consumers. Okay. Amazon producer is one on Flipkart, maybe Facebook consumer. Sorry, Amazon producer, Facebook consumer, Instagram consumer, LinkedIn consumer. Okay. If I send, maybe Amazon sending one message. I'm searching for the clothes. How many people will receive the message? 3 people will receive. There is no concept like Facebook received, that means already gone. These 2 will not receive. There is no concept like that. Okay, one message can receive multiple peoples, multiple consumers. That is also possible. You want to check that? You want to check that? Just take. This is Amazon producer. In Amazon producer, I'm searching for t-shirts. I'm sending this message to Kafka. Who will receive? Only Facebook, only Instagram, only LinkedIn, or 3. Check. I'm sending message. Send. Go to Facebook. Received. Go to Instagram. Received. Go to LinkedIn. Received. Searching for t-shirt. That means no matter about how many consumers, one message can consume by the multiple consumers. That is possible. Okay. I think it is clear. If it's not clear, let me know. We'll go for next. What is Kafka cluster? Kafka cluster is a combination of multiple Kafka brokers. Okay. By seeing diagram, we can say here combination of multiple Kafka broker we can call as a Kafka cluster. This is one broker. This is one broker. This is another broker. These are brokers. These 3 combined as a one simple concept called Kafka cluster. Okay. Combination of one or more Kafka brokers we can call a Kafka cluster. So only one Kafka broker will be function as a Kafka controller. What is Kafka controller? Kafka, maybe this is a leader. One broker will act as a leader. That leader is down. Who will elect another leader? Next leader. Zookeeper will be responsible. Example, Kafka broker 1 is down. Kafka broker 1 is down, then who will elect the next leader? That is zookeeper will be decided. Okay. Okay. So we'll go for next one. So what is the type of clusters? We have different type of clusters. Different type of clusters. One is single node, single broker. Single node, single broker. Second one is single node, multi-broker. Multi-node, multi-broker. Just try to understand this one. Just try to understand. I'll give more picture on this. Okay. Okay. First we'll go single node, single broker. Single node, single broker. What is the meaning? What is the meaning? So I installed Kafka in my system. This is my system. Single node. Single node. Here I started a Kafka server. This is a Kafka broker. It started here. That means here this is only one node, one Kafka broker. Started Kafka broker. That is called single node, single system. Okay. Second one, single node, multi broker. What that meaning? We can take only one system, single node. Here we can install multiple brokers. Maybe this folder A. Here I started Kafka broker. We started Kafka broker. Here maybe folder B. I started Kafka broker. This is broker number 1. This is broker number 2. Okay, this is single node, multiple nodes. Like that, we can launch multiple nodes, multiple brokers. Single node, multiple brokers. It's clear? If these two are clear, next one is what? Multi-node. Okay, multi-node. Multi-node and multi-brokers. What the meaning? Multi-node means multiple systems. There are multiple systems. 1, 2, 3. We can start broker here. Folder A. Start Kafka broker. Start Kafka broker. Kafka broker. This is the first broker, this second broker, third broker. Multiple nodes, multiple brokers. Like that, diagram will tell clearly. In the first diagram, only one broker is there. Consumers, producers. Consumer, producer is common. Okay, second one is single node, multi-broker. In the single system only, I launched multiple brokers. Broker 1, broker 2, broker 3. Okay, third one is multi-node, multiple cluster. See, there are Kafka node 1, Kafka node 2. In the Kafka node 1, there are 3 brokers, 3 places I started. Like here I started, Kafka broker. Okay. In the broker node 2, here I started, Kafka broker. So this is multi-node, multi-broker cluster. Simple one, architecture wise. Next one is Kafka broker. What is the Kafka broker? Kafka cluster is combination of one or more servers. Already you know, Kafka broker, Kafka cluster is combination of one or more servers. Kafka servers. Okay, Kafka nodes, we can say. Each server in the cluster is called broker. We can call it Kafka broker. A broker handles the hundreds of megabytes of writes from the producer and this from the consumer. What that meaning? This Kafka broker can accept hundreds of megabytes of data from the producer while writing. Okay, while writing, we accept the data to write into Kafka broker. This may be large size, hundreds of megabytes. Okay, and also consumers reading. This also will support. Kafka broker will help to read data from the Kafka broker to consumer. Okay, while writing, it will support hundreds of megabytes. While reading also, it will support for the consumer. Okay, retain as public messages respective of what a consumer. Okay, whenever. Okay. So what is the meaning? So one more thing I had to cover is very important in terms of interview. This is the Kafka topic. Maybe I created mobile topic. Okay, here producer is Amazon storing data. Amazon storing data into this topic, and consumer maybe Facebook reading data. This already you know. So Amazon today write 10 messages, tomorrow 20 messages, day after tomorrow 30 messages. Okay, again 10 messages. That means not daily some messages written. Don't consider about count. Daily some messages written to the corresponding topic. This is repeating. Amazon is a producer, Facebook is a consumer, and Amazon writing data to the topic, Kafka topic. This is Kafka cluster. This is a Kafka topic. Writing the messages. How many days this message will write? We keep writing some data. Maybe after 1 year, how many messages will come?
Hi, Chenju. Sorry to disturb you in the middle. Topic and broker, how can you differentiate?
Topic is where we store data.
Topic
broker like where we started Kafka server.
Pardon me.
Kafka server actually.
Cluster contains so many brokers.
Cluster contains so many brokers. Okay, in the brokers we can create a topic to segregate the messages, to categorize the messages.
So inside broker we can create so many topics.
Yes, we can create so many topics.
Okay.
That is correct. Why? Because so whenever the producers are sending messages, how can you categorize? Categorize purpose we can do the topic creation. So mobile type we can write into one topic, laptop types we can write another topic. So in that, so Facebook wants to only read the data from the mobiles, so it will connect to the mobile topic, no matter about the Kafka broker. Okay, and Insta wants to read from the only laptop broker, laptop topic, so it will connect to the laptop topic and read the data, but no matter about the Kafka brokers, how many brokers are there. Okay, so here retention. What is retention? So producers, maybe Amazon, Flipkart, whatever, keep writing data from the keep writing data to the topic, some topic, example mobile topic. So how many days it will be stored here? If you store 1 year, what will happen? Daily hundreds of megabytes data will come. How we will store that much amount of data in Kafka cluster? There is a cost effective time. So cost effective operation here. To store that much amount of data, there is a problem. We have to store, we have to buy large amount of storage. To avoid that, what we will do? There is a retention factor. Retention means when we have to delete the data from the Kafka topic. How many days we have to store? How many months we have to store? How many hours we have to store? By default, Kafka will store only 7 days data. Once the 1 week completed, the whole data will be deleted. Okay, this is first day, second day, third day, fourth day, fifth day, sixth day, seventh day. Again, 8th day coming, that time this data will be deleted. 9th day coming, whatever that this data will be deleted from the Kafka topic. That means what? We can store, but it's not good practice to store the data Kafka messages in large time. Because we have to store that data, that is a very cost-effective operation. To avoid that, Kafka admin will decide based on our complexity, based on our requirement, our need, project requirement, they will configure some retention time. By default is 7 days. That means today we send data to the Kafka topic. After 7 days, that will be automatically deleted, even if you don't delete. Okay, if you want to increase the time, okay, I want to store at least 1 month. Okay, then configure this property, retention time, 1 month, 30 days. Then Kafka will store your data, your message in 1 month. After 1 month, automatically delete it. That is called retention. By default is 7 days. Okay. So same producers publishes new message to a specific topic. Already we know. Producers always write message to the topic. Okay. Producers does not care with the partition specific message they return. So producers basically it will not consider, it will not take care where it is writing, which broker, which partition, these many things not required. Just will produce a message and leave it. Internally, zookeeper component will and leader broker, leader partition will take care to storing data. Okay, directing message to partition done by messaging key. Okay, so before that, one more thing is always I am sending producer will send message to the Kafka cluster. Will send message to the Kafka cluster. What is this message first? What is this message? So message can one event some data that has two parts. One is key part and is value part. Key part is maybe we can write string only thing, but value we can write anything. Maybe string byte array, or maybe some binary data, JSON data, XML data, whatever we can write. Value can be anything. But string key will be only string or not sure that I will take. Finally, message is a combination of key and value. Whenever we are sending a message to the Kafka topic by producer, okay, that Kafka message contains two parts, key and value. Value is the actual message, key to identify that message. Okay, and if you don't provide key, by default, this is a null value. This is null. If you don't provide key, by default value is null. So anyway, we have to provide value, otherwise we cannot send a message. Whatever data you are sending, that will be a value by default. Okay, that's what I am saying here. Okay, what I am saying here, directing message to the partition done by using message key. So based on key, it will decide which partition has to change, and that will generate a hash of the key. Okay, that is hashing related functionality. That actually I'm not much aware in that how to generate hash key for this, but message contain a key and value. Okay, every message as a producer publishes in the form of key and value. Already told, every message is a combination of key and value. Kafka consumer. What is consumer? Consumer is to read data from the topic. Consumer read data message from topic. Okay, the consumer subscribes one or more topics. Okay, that means what? Here consumer will subscribe. Flipkart, sorry, Facebook is a consumer, Insta is a consumer, LinkedIn is a consumer. So consumer, only one consumer can consume multiple consumers can consume from the same topic. That is possible. Maybe multiple consumers can consume different topics. That is also possible. Okay, Facebook read from the mobiles. Instagram also can read from the mobiles. LinkedIn also can read from the mobiles. That is possible. Multiple consumers can read from the single topic. That's what I'm saying here. The consumer will subscribe to one or more topics, read from the sequentially. Consumer keep track of messages, what it has consumed. So this is also one important topic, abstract management. Okay, this is Kafka topic. This example I'm saying, this is Kafka topic. Here we are sending messages. Producers sending messages. So producers, these are consumers. Okay. While producers sending message, that message is a part of key and value. Already you know key and value. Okay. How it will store? Example, take this array 1, 0 like this. So every message has an offset 1, 2, 3, 4, 5. Okay, this is 5. If you send more messages, it become new. Okay. So first message, this is hello or hi. This is hello. Where? This is where are you? Different messages. Okay. Mobile, laptop. This is different messages producers are producing. Different messages producers are producing. How to store? How we can differentiate? While consumer reading, how it will read? So while consumer reading, first it will read the hi. That is fine. Then now next time it will go on how to know consumer what data it has to fetch. Previously what it is fetched. Previously I got hi. Next I want to get the hello. How this no consumer? How it will remember? Maybe consumer may confuse, right? Previously, I don't remember what I read, so I can read again. I can read again same hi. Previously, I read hello, I can read again same. This is a problem, right? Consumer, if you don't remember what message previously read, okay, how it will read next data. To avoid that, we have offset. This part we can call it offset. Every message has some unique value, integer value, that is called offset. Consumer, while consumer is consuming data, whenever first consume, it will get the high. Corresponding high, what is the offset? 0. It will remember the offset value. Next time it is going, it will tell Kafka topic. I read last value is a 0 position. I want to get next value. Next value is hello. Get this value. Okay, update the last offset value is 1. Okay, again go to topic last value I read as a 1th position, 1th offset. So that means next value is where are you? Where? Like that, based on offset, consumer will remember what is the last read value from the topic. Otherwise, if you don't maintain the offset value, consumer may confuse what value last read. Again, it may be a chance of read the duplicate data, and also chance of read the missed data also. If you don't remember this value of offset position, consumer go and get the random value, 5th position. Then get random value, 2nd position. That's not correct. That is not correct. So do avoid this kind of things. It will maintain the offset. This is the offset management, offset value. This is integer value, but it will keep increment. There is new message coming, increment the number. Like that. Okay. And when this value will be removed based on the retention policy. So this issue may be 7 days back. Our retention policy 7 days. So we'll delete this. Like that, data will be deleted. Okay, this is about Kafka consumer. Each partition has a unique offset and it is stored. That is already I told. An offset is used for last consume message. Consumer can stop reading without losing the current state. Without losing the current state, will get the next value. Okay. And replication factor already told. How many times repeated? Kafka topic already told. This is a place to store the data. Bunch of messages can store in a single place called Kafka topic. Okay, data stored in topic. In addition to, we can replicate and partition. This is okay. Okay, next we'll see our part, developer. What developer has to do? What developer has to do? This is up to administration part and also some theory part about Kafka. Now we will discuss, we'll write some code, Java code, how to read data or how to store data. So we'll write some code for the producer and consumer both places. Okay, any questions as of now? No questions, sir? Okay. So now we'll discuss scenarios. Okay. Now we'll discuss scenarios. In the code, as a Java programmer, how to write code for to consume a message or how to write code for to produce a message to particular topic. First, how to connect to the Kafka cluster. How to connect. Okay. So example, take a simple example. Your company using Kafka. In your project, there is a Kafka component is there. how to increase size. When I open this Kafka. I'm opening another one. Okay, so this is Kafka cluster your company using. Okay, your project is using the Kafka cluster. You are developer, you have to read the message from the Kafka. Maybe you are a developer, you have to write message to the Kafka. This is producer, this is consumer. Producers always write data to the Kafka topic. Consumers always read from the Kafka topic. Okay. Now your manager given a task to you. There is one topic. Topic name is test. Topic name is test1. Okay. Or else transactions. Transaction is a topic name. You have to write whatever user done some payment. Whatever users done some payment from the application. Maybe just example, this is a red bus. This is red bus. This is a banking, some HDFC. Okay, red bus do some transaction. So that transaction data, maybe transaction data, what is the basically amount, user ID, okay, account number, like that some data it will be provided by the user input that we have to write to Kafka. This is the producer. Writing means what? Producer. Okay, first we'll see this part. How to write to the Kafka cluster, corresponding topic. So first we need to know what the Kafka IP address, Kafka cluster IPs. That means broker details. Okay, we need to know broker details and topic name. And I'm not thinking about security. Security not enabled right now, so I'm not thinking about security. So to connect our custom producer. This is a red bus custom producer, but not console. Console means only to work with practice here. This is console producer. To use as a producer in our application, we have to design a producer that is called custom producer by using Java, .NET, PHP, Golang, whatever. Okay, I want to write a custom producer, red bus producer. Okay, to write some data to Kafka cluster, I need to know what are Kafka broker details. Kafka programming, which IP, which port number, and the topic name. Okay, first we will see by using plain Java without using Springboot, Hibernate, whatever. Just use plain Java, how to work with as a producer and consumer. I'm writing here. Yes, I create a simple project. This is simple noun project. There is no Springboot here. Kafka Java example. Here, just see XML file, POM XML file. What are different dependencies I added for the Kafka purpose? This is the Kafka client, Kafka libraries for Java. Apache Kafka client version is 3.4.0. You can change later according to the latest version or lower version. Now, why add log4j, SLO4j? Internally, the Apache Kafka clients depends on log4j, so SLO4j. That is why I added this only for supporting dependencies. This is the main one is Apache Kafka group ID, artifact ID, Kafka clients. So With this, I'll get some jar files. With the jar files, I can work with. See this Kafka clients, it's a main jar file. These are depending on different jar files. Now, jar files is fine, it's simple. Next, we'll see the producer example, custom producer. How to write custom producer? I'm writing here on producer class, Redbus producer. This is my producer, my own producer. That's why I can call it a Redbus producer. Okay, Redbus producer. What code we have to write? First step is connect to the Kafka cluster with broker IDs, broker details. Next step is write the message to the Kafka topic, some topic name. These steps we have to do. Okay, to write that we have some code, some API code already given by the Kafka framework. Okay, what are those? First, we'll store all the details. First, we'll store all the details. See, broker servers, localhost 9092, same whatever we entered here. Broker servers, where is our Kafka cluster running? Serialization and deserialization. What is a serialization and deserialization? Why did deserialization? 1 second. Should be deserialized. I'll tell you about what is serialization. Why we need to serialize. So while transferring the data from the network through network from the producer to Kafka cluster, we have to do serialization. We have to convert into encrypted format. Some way of encrypted format. Okay, maybe example someone can hack it. Maybe think like that. Okay, to convert that serialized format, we have to use the key serializer. Why key serializer? As a message contain key and value. So I have to convert. I have to encrypt key and value both. So to encrypt the key, what is the serializer? What is the encrypt the value? Serializer. I'm taking both as string only. Tomorrow, if you are working with a JSON, you can use JSON serializer. If you are working with a XML serializer. Like that, you can change according to your requirement. Right now, I'm working only with the string, plain string. Okay, so I'm setting all those things in a single property file. Already properties we know, collection objects. Properties used to store the key and values. Keys can be duplicated, values can be duplicated. Okay, broker server, key serializer, value serializer, group ID. Group ID for the consumer purpose, consumer group. Okay, multiple consumers are reading from the particular topic. Now we are set only in a one property style. Now we have to connect to the Kafka broker. Connect to the Kafka broker. What we can do? This is the line. This is the line to connect to the Kafka broker. Okay, this is the line to connect to the Kafka broker. New Kafka producer. So I'm telling the producer, my Redbus producer. To want to know where is Kafka, I given input as a property file. In the properties, there is a broker servers, booster servers. Booster servers tells where the Kafka running. Okay, and what is serializable. Whenever sending message, how to convert into encrypted format. That is called serialization. That details I'm giving to you. So go and connect. Go and connect. This Redbus producer will connect to the Kafka cluster. Now we want to write some messages. We want to write some messages. How to write? There is one method. There is one method. Message update now. I want to send one message. Hi from Redbus. Simple message. Okay. What is the topic? This is the topic. Topic name is what I told. Topic name is transactions. Transactions. I'll use only small case. to avoid case sensitive transactions. Transaction, okay, fine. Transaction is topic name, key is a message key, value is a message value. Okay. Now I want to send to the Kafka cluster. There is one method on the producer class, send method. By the send method, we can send a message. Okay. In this case, this transaction topic already exists or not. So this transaction topic already created or not. How we can check? How we can check the transaction topic already created or not? I did not create it. Maybe someone in my team already created. How to check that? You can check the existing topics. You can check the existing topics. List something is there. Let's try this. Topic. The topic. Where is the topic? So we can check the result command. Let me try. Okay, I'll take from Google directly. Getting started. Here we can see docs. Here we can see somewhere some commands. One sec, must be not working. There is one command to check all the topic names. Okay. List not correct. One second, I will search Google. List the Kafka topics. This is the command. Kafka topic research icon list. Okay. I'm taking into Notepad. I will try bin Windows. One list. Bootstrap server. Just try this one. It should be so. What are list of available? Windows Kafka topic search. One second, let me check. Topic. So this is bad, not SH. Okay, I have mobile topic. I have static topic. I have static one topic. I have STATCH. Okay, but I don't have transaction topic. How to create topic with a transaction as a topic name? How to create topic? It's a transaction as a topic name. This is the approach. This is the command. This is the command. So by using this command, list existing topics in the Kafka cluster. This is existing topics from Kafka. The below command is to create new topic. Topic name is transaction. Topic name is transaction. Transaction. Yes, that's fine. Okay. Now run this command and create new topic. It is created transactions. Okay. And I want to send my code wants to send some message to the simple hello from the red bus. One message to the transaction topic. Okay. This is producer is sending. So run this, it will send the corresponding message to the topic. How we can check it is sending or not? We have to create one consumer to check or to read data from the corresponding transaction topic. Okay. I think not confusing, simple, straightforward. I created transaction topic. Okay. And producer, red bus producer sending the message. And we have HDFC consumer. HDFC consumer we can write manually, but for now we can use console consumer. Console consumer we can design. Maybe we can start. Console consumer we can start and see that message sent by the red bus producer or not. Okay. Transactions. Transactions. Okay. So, the bin consumer that okay, we not found. We have to move to the folder. Okay. Now run again transactions. Okay, it is listening. Now my code I'm running here. Okay, my custom producer sending some message to the Kafka. It should be received by the consumer. See here, is sent. It is sent. There is no error. It is sent. Transactions not received. Not received. Wait 1 second. Let's see. Should be shown here. Transactions spelling mistake. TRANS. Transactions is correct. Now what topic we created? Topic created is fine. Now it is sending the message, but wait not received. Is send. You check again. Send. Group ID. Second, let me check. I had to add one more property. Group ID to the console consumer. Let me check what is the property we have to add more. Group ID. No, hyphen group. It's correct. Hyphen GRO group equal to group ID listening. This is the one group hyphen ID. Message sent. Console consumer. It's not started. Okay, let me run one more. I'm creating one more consumer. One consumer create custom consumer. H3FC consumer. Okay, here I have main method. Okay, so here take this code. Pick them. Action. Now starting consumer also. Let's write. Okay, now producer sending some message. Message sent. Says consumer. Not received. There is some issue, I think, seems. It should be received. So this time, let me check. Meantime, I will try to again. Okay. So what I'm doing here, maybe single message sending and receiving may take some time. Okay, some seconds time. To avoid that, I'm sending multiple messages, bulk messages. What loop will do? This Redbus producer keep sending messages to the topic. Keep send message to topic. Okay, 1, 2, 3, 4, 5, 6, 7 like that. This topic is sending. Meantime, I started the console consumer. This is console consumer. This console consumer will read from the topic, transaction topic, and it will be printing here. Console means what? It only print, cannot do anything. This is the functionality, and this is only for console consumer and the custom producer. We know now to want to design one task, want to write a task to write some messages to the Kafka by using Java, plain Java. We can know how to write messages. Okay, simple properties object, Kafka producer, then produce record, send message. Simple. Just I'm putting into loop because to send a multiple messages. Okay. These lines of code will send the message to the Kafka topic. Key is a key comma counter. Key is a key comma counter. Value is a this one. Console consumer show only value. It will not show key. It will not show key. Only that's why we are seeing a value part. Okay. Now we know how to send message from the Kafka. So how to send message to the Kafka topic by using custom producer. Now we'll see how to do custom consumer. This part now. Okay, this part how to write. Okay, this is the code HDFS consumer. This HDFS consumer will keep read data from the transaction topic. From transaction topic, keep read and just keep print. For that, this is already just for connection purpose. Okay, after reading, how to deserialize. Serialize we know encrypting, decrypting, deserialize, decrypting, value serialize. Okay, now Kafka consumer. Okay, provide the connection details, reading, connecting, and reading data. From which topic? Topic name. Topic name I provided. Now it will do to poll. Poll means what? Keep checking the topic. Keep check the topic. Any new message come, then print. New message come and take the consumer. New message come take the consumer. There is no new message, just wait. Don't do anything. Don't do anything. Okay. Now it will do the polling. Polling for every 10 seconds, I think, it will go and check the data. Okay, after getting data, it will get the records. The records will print into loop. That message contain offset. Offset I told already, offset for to remove the, maybe to avoid the duplicate read. Key, message value. Now I'm running the console, sorry, the custom consumer also. Now see that custom consumer. It will read or not. See reading. Offset is 60 messages. Key 23, value 23. Hello, hi, message from the plus 23. Again, new message, get from the topic, print. Again, new message, get from the topic. Go to check in the new message. Every 10 seconds, it will go and get the message. Okay, after getting message, from here up to your choice, you are going to print, you are going to insert in your database, you are going to do something else, you are going to call this API call, up to your choice. Okay, this is only I'm telling for the how to write, how to read data from the Kafka. How to write to Kafka topic, how to read the Kafka topic. This is simple Java, plain Java. So here not much logic. Now I'm going to cover. This is old approach anyway. Now we are using advanced technologies like Springboot. In Springboot, how to write same here, consumer or producer. Okay, any coding changes are there? Yes, definitely, because Springboot is mature. Definitely, Springboot is mature. So Springboot knows how to configure automatically. In the Java, you given the consumer and producer connection details every time. For consumer you given, producer you given these all these things. But Springboot, these things are not required. The configuration part always Springboot will be managed. The configuration part you don't have to write. For the usage part, to sending a message, your message, to read the message, that only you have to take care. Okay, so go to Springboot application. It's already designed here. What are difference you need? Already you know, starter web, this is simple. Already you know. Kafka dependency, you can select from the Springboot starter. Okay, if you want to go to the start.spring.io, how to create the Springboot. So what is this start.spring.io? This is very much important question. What is Spring Initializer? Yes, I am covering the interview question. What is Spring Initializer? Spring Initializer is a tool or a website. Spring Initializer is a tool or website. It is allowed Springboot based project based on our custom starters. We can select starters here. We can generate a Springboot project. After generating, we have to import into the project. Okay, fine. See that here. I need Java Maven project, Java version 2.7 and Java version, where to mention Java 8 like that. Okay, here Java 8 I taken. Right. Okay. Project name is, what is the project name? Springboot Kafka. Springboot Kafka. Next, dependencies what we need. We need web. Web for what? To create endpoints. Next, we need Kafka dependency. Springboot Kafka. In second, let me get charger. The Springboot Kafka. If you want to add accelerator, you can add yours. This here mandatory. Then click on generate. It will create a project and import into the Eclipse IDE. Okay, I imported. I have web Kafka, dev tools, test not required. Okay, now see the code on configuration wise, SRC main properties. Here what I mentioned, same. This is consumer, this is producer properties. This is producer properties. This is consumer properties. Just we have to tell the key and values to the Springboot. Springboot automatically create the producer object, consumer object directly without writing these main lines of code every time. Okay, simply we create for you. This is producer. What is the bootstrap servers is common. Okay, group ID, consumer group ID, offset. What is the reset offset? Reset of separate topic for this. Like what offset data I have to read. Okay, the corresponding offset not found. On string key serializer, value serializer. Not much difference here. These are all common. Bootstrap servers, serializers, and the group ID. Okay, then go to code. Code is also very much simple. This is producer. Kafka producer. So in the normal application, Java application for the producer purpose, what we written, Redbus producer, see this many lines of code is there. But if you go Springboot, only 2 lines, only 2 lines, even 1 line I can say. This is the 1 line, this is the another line. Send. We have one template object, Kafka template. Kafka template internally manages all these things. Kafka template internally manages all these things up to here. Next, only you have to call a message, send message. That is called producer template send message. Okay, simply send message we have to call. So if you use this method, Kafka template send, internally these many lines of code will be written connecting to Kafka topic, all those things. Then send your message to this topic. Topic name is right now we change it transactions. Transactions. This is a Kafka producer, custom producer by using Springboot. Custom consumer by using Springboot. In the custom consumer, in normal application, Java application, simple Java, what we did, this many lines of code is there. This many lines of code is there. Okay, but you see, Kafka consumer, nothing, only one annotation will be enough for this. Kafka listener. This listener always will be check this topic. Always check this topic. Always check this topic. What it will do? It will check the corresponding topic, always monitor the topic, and any new messages come, and that new message will be inserted to this message variable. That message variable we can print or you can insert into database, insert into some different application. That is up to your choice. Okay, just I'm running this application, Kafka listener. Once you start Springboot application, automatically this will be enabled. Starting this 8080 I will use okay, I will use some other port. How to change the port number? Please, how to change the port number? Unmute, tell me answer how to change port number.
Properties. Server dot port.
Okay, 2023 I'm using. Now again start application. It is reading the data. It is reading data. So right now what I will do, Springboot is a consumer. Springboot is a custom consumer. This one. And Java is a plain Java is a producer. Redbus producer. Like that I'm reasoning. So here I'm starting the Redbus producer, starting the data and sending the messages. Springboot is reading. See here Springboot reading. Right? This is Springboot. Springboot Kafka example. This is the class. Kafka consumer. This is the consumer will always read the topic and the message whenever received, inject into here. That is just printing, not doing anything. Message received. Okay, just try to practice. Do yourself. It is very easy. Okay, by following the video, just do practice. Do same as it is what I did. Then later you can do your experiment. Your own creating your own topic, inserting your own message. You work with JSON message also. Okay, fine. This is about Kafka. If you have anything, ask me. Else, I'm stopping the recording.